As some examples of agentic AI applications. One task that many businesses carry out is invoice processing. So given an invoice like this, you might want to write software to extract the most important fields, which for this application, let's say is the biller, that would be Techflow Solutions, the biller address, the amount due, which is $3,000, and due date, which looks like it is August 20th, 2025. So in many finance departments, maybe a human would look at invoices and identify the most important fields, who do we need to pay by when, and record these in a database to make sure the payment is issued in time. If you were to implement this with an agentic workflow, you might do so like this. You might input an invoice, then call a PDF to text conversion API to turn the PDF into maybe formatted text, such as markdown text for the LM to ingest. Then the LM will look at the PDF and figure out, is this actually an invoice? Was this some other type of document that it should just ignore? And if it is an invoice, then it will pull up the required fields as well as use an API or use a tool to update the database in order to save the most important fields in the database records. So one aspect of this agentic workflow is that there is a clear process to follow. It's identify the required fields and record in the database. Tasks like these with a clear process you want followed tend to be maybe easier for agentic workflows to carry out because it leads to a relatively step-by-step way to reliably carry out this task. Here's another example, maybe just a little bit harder. So if you want to build agents to respond to basic customer order inquiries, then the steps might be to extract the key information, so figure out what exactly did the customer order, what's the customer's name, then look up the relevant customer record, and then finally draft a response for human to review before the email response is sent to the customer. So again, there's a clear process here, and we will implement this step by step, where we take the email, feed it to an LM to verify or to extract the order details. And assuming the customer email is about an order, the LM might then choose to call an orders database to then pull up that information. That information then goes to the LM to then draft an email response, and the LM might choose to use a request review tool that, say, puts this draft email from the LM into a queue for humans to review, so that can then be sent out after a human has reviewed and approved it. So customer order inquiry agents like these are being built and deployed in many businesses today. To look at a more challenging example, if you want to build a customer service agent to respond not just to questions about an order they place, but to respond to a more general set of questions, anything a customer may ask. And maybe the customer will ask, do you have any black jeans or blue jeans? And to answer this question, you need to maybe make multiple API calls to your database to first check the inventory for black jeans, then check inventory for blue jeans, and then respond to the customer. So this is an example of a more challenging query where, given a user input, you actually have to plan out what is the sequence of database queries to check for inventory. Or if a user asks, I'd like to return the beach towel I bought, then to answer this, maybe we need to verify that the customer actually bought the beach towel, and then double check the return policy. Maybe your site returns only 30 days within the date of purchase, and only if the towel is unused. And if return is allowed, then have the agent issue a return packing slip, and also set the database record to return pending. So in this example, if the required steps to process the customer request are not known ahead of time, then it results in a more challenging process where the LM-based application has to decide for itself that these are the 3 steps needed in order to respond appropriately to this task. But you learn about some of the latest work on how to approach this type of problem too. And to give one last example, maybe an especially difficult type of agent to build, there's a lot of work on computer use by agents, in which agents will attempt to use a web browser and read a web page to figure out how to carry out a complex task. In this example, I've asked an agent to check whether seats are available on 2 specific United Airlines flights from San Francisco to Washington, D.C. or the DCA airport. The agent has access to a web browser they can use to carry out this task. And in the video here, you can see it navigating the United website independently, clicking on page elements and filling in the text fields on the page to carry out the search that I requested. As it works, the agent reasons over the content of the page to figure out the actions it needs to take to complete the task and what it should do next. In this case, there's some trouble checking flights on the United site, and instead decides to navigate to the Google Flights website to search for available flights. On the Google Flight, you see here it finds several flight options that match the user's query, and the agent then picks one and is taken back to United website, where it looks like it's now on the correct web page, and so is able to determine that, yes, there are seats available on the flights that I asked about. So computer use is an exciting cutting-edge area of research right now, and many companies are trying to get computer use agents to work. While the agent you saw here did eventually figure out the answer, I often see agents having trouble using web browsers as well. For example, if a web page is slow to load, an agent may fail to understand what's going on, and many web pages are still beyond agents' abilities to parse or to read accurately. But I think computer use agents, even though not yet reliable enough to use in mission-critical applications today, are an exciting and important area of future development. So when I'm considering building agentic AI workflows, the tasks that are easier will tend to be ones where there is a clear step-by-step process, or if a business already has a standard procedure or standard operating procedure to follow, and then it could be quite a lot of work to take that procedure and codify it up in an AI agent, but that tends to lead to easier implementations. One thing that makes it easier is if you're using text-only assets, because LMs, large language models, had grown up really processing text, and if you needed to process other input modalities, it may well be doable, but it maybe gets a little bit harder. And on the harder end of the spectrum, if the steps are not known ahead of time of what's needed to carry the task, like you saw for the more advanced customer service agent, then the agent may need to plan or solve as you go, and this tends to be harder and more unpredictable and less reliable. And then as mentioned, if it needs to accept rich multimodal inputs, such as sound, vision, audio, that also tends to be less reliable than it only had to process text. So I hope that gives you a sense of the types of applications you might build with agentic workflows. When implementing one of these things yourself, one of the most important skills is to look at a complex workflow and figure out what are the individual steps so you can implement an agentic workflow to execute those steps one at a time. In the next video, we'll talk about task decomposition. That is, given a complex thing you want to do, like write a research report or have a customer agent get back to customers, how do you break that down into discrete steps to try to implement an agentic workflow? Let's go see that in the next video.